Okay, hi everybody. So we're going to prove the first limit law. There's several limit laws in your book, and one of the limit laws says that if we have this limit, the sequence Zn approaches Z, so here are the Zn's, and maybe they infinitely approach Z. And if we also know that the Wn's, here maybe these are the Wn's, and they approach some point W, and this is all happening in the complex plane somewhere, so like, I don't know why I'm being predicted. So anyway, but Z and W are actually complex numbers, so they're vectors, so we can add them. And here is Z plus W. And each of these Zn's is a vector, and this Wn is a vector, so we can add them. And we get Zn plus Wn. And we could do that for all of them, so we get now another sequence of points. The claim is that sequence actually approaches this complex number. Okay, so this new sequence, we could even call it, say that x sub n is defined to be equal to z sub n plus w sub n, which we were given. We have these two sequences. So we define a new one, and we say that that new sequence actually converges to the sum of the limits. I mean, one way to say this is the limit of a sum is the sum of the limits. Okay, so that's what's going on. Let's just prove it. So how do we prove it? Proof. First, we tell our reader what we are assuming. We assume we have two sequences. We assume that the sequence z sub n converges to z, and that the sequence w sub n converges to w. We need to prove that a new sequence, let's even just be very explicit, x sub n, whose definition, the formula for it is z sub n plus w sub n, converges to z plus w. Okay, and so that's what we need to prove. So we need to show, that means, what does all this mean? So what does all this mean? What does this all mean? So I'm helping my reader by explaining Zn goes to Z means that for all d there exists a capital N such that when you go past capital N, you have that the Z sub n minus Z is less than D. Okay, so we have control over Zn minus Z. We have control over that because we are assuming this. So assume. Also, we are assuming, and I'm going to help my reader by reminding them what it means. Wn goes to some complex number W means the same thing. We have control over the difference here. Now, what we want is that Zn plus Wn goes to Z plus W. But what does that mean? It means that for all d, we need to find a capital N such that when we go past that cutoff, we have, okay, now be very careful, this minus this is less than D. Okay, so what am I saying? Now the new sequence, I could have written x sub n, but anyway. So this piece minus this piece. Okay, this is the limit, and this is the formula for our sequence. Okay. So the key is we have control over these pieces, and so we should rewrite our goal. So no matter the d, positive real number, we need find a capital N such that n greater than capital N implies, I'm just repeating myself now. Wait, what? Oh, this is a plus. Oops, this is a plus. Plus Wn minus. So you have to be very careful about this. Okay. So this is our goal, right? And so in particular, this piece is our goal. So let's calculate. Let's calculate with this. That is true if and only if, and now I'm going to rearrange Zn minus Z, so the minus Z I'm going to bring over to the Zn. Why? Because we have control over this. It was part of what we assumed to be true. Okay, and now the minus W, I'm going to put with the plus Wn. Okay. Now here's the thing. Here's the thing. Look at this thing. This is, yes, it's a subtraction of two complex numbers, but let's view it as just a vector. It's just another complex number, so it's a vector. And W sub n minus W is a complex number, so it's a vector. Oh, V and W is not a great name. Let's call it A and B. This is going to be A, and this is going to be B. And what we're seeing here is that if we have some complex number A and some complex number B, and we add it, we're doing A plus B. Maybe this is the complex number B. So really, secretly B is right here. But then this is A plus B. And here we have a triangle. Triangle right there. And what we know is that this side is the length of A plus B. This side has length A, and this side has length B. And the triangle inequality is so useful. It just says that the length of any side of a triangle should be less than or equal to the sum of the lengths of the other sides. In other words, applying it to this thing, which we hid detail and called this A, we hid detail and called this B, we have that Zn minus Z plus Wn minus W is actually less than or equal to Zn minus Z plus Wn minus W. Okay? But we have control over those things. In particular, choose D over 2. Choose D over 2. In the definitions of Zn converging to Z and Wn converging to W, then we know that there exists some capital N1 such that going past capital N1 implies that Zn minus Z is less than D over 2. For any distance we choose, in particular, we can choose D over 2. Also, because we know this, because of Wn converges to W, we know that there exists an N2, such that going past that cutoff implies that the Wn minus W is less than D over 2. Because if this converges for any desired distance, we can get that close. There's some cutoff. Choose capital N equal to the max. Whichever one is bigger between these two cutoffs that we knew existed from our assumptions that these converged. Then, if n is greater than or equal to capital N, we have n is greater than or equal to n1, and n is greater than or equal to n2. So that star and double star hold. So star and double star hold. But then, going past capital N means that Zn minus Z plus Wn minus W is less than or equal to, by the triangle inequality, Zn minus Z plus Wn minus W, which by star and double star is less than or equal to d over 2 plus d over 2, which is d. So star gave us that, and then also double star gave us that. And this is exactly the definition of our sequence. So now we've shown that if we go past capital N, we have this thing is less than D. Well, I guess right here we have strictly less than. I mean, the strictly doesn't really matter so much here, but we do have this because star and double star have strictly less than, so we get strictly less than. Okay, we're done now. This is a really good, this exact same argument with the triangle inequality comes up so often in math. It is really worth your time to go and do a blank sheet of paper and try to figure this one out again. We assume this and we assume this. We need to prove this. So apply the definitions and carefully see that, assuming these things means that for any distance, in particular for d over 2 and d over 2, because when we add these together, we will get less than d. And yeah, this is kind of a nice argument. So try it yourself. Quiz on blank sheet of paper. We have shown that the limit of the sum is equal to the sum of the limits.